Dear students, we just completed the chapter Isomerism in Coordination Compounds. Now let's discuss some questions based on this chapter. The first question is, draw geometrical isomers of dichloro base ethylene diamine cobalt ion. Cobalt nahi, chromium ion. Sorry. Okay. So, draw geometrical isomers of dichloro bis ethylene diamine chromium ion. One thing, before writing the answer, one thing you need to take care that you should first understand the difference between geometrical and optical isomers. There are two types of geometrical isomers, cis and trans. Cis means two similar groups are present on same side, and trans, two similar groups are present on opposite side. So how we can draw the geometrical isomers of this complex? See the answer. Here you can see that two similar groups, chlorine, they are on opposite side here. So it is a trans isomer, while here two chlorine, they are on same side. So it is a cis isomer. Next question is, draw, geometrical isomers or cis-trans isomers of triamine, trichloro, cobalt complex. Triamine, trichloro, cobalt complex. Now, if you see this complex, it is of Ma3B3 type and it's an octahedral complex. So, when we draw the cis and trans isomer of this complex, we get this answer. Here you can see the three ligands, same ligands, they are present on one face. So, it is also called as cis isomer or facial isomer. In this case, similar ligands are present at 1, 2 and 3 position. Or we can say similar ligands are present at 4, 5 and 6 position. So, such isomer is called as facial or face isomer. And when two similar ligands are present on opposite side like this and one is present here, such isomer is called as, or they are present at meridional position and hence it is called as mer isomer or trans isomer. Third question is, draw all possible geometrical isomer of this complex where diamine, dipyridinium and dichloro are the ligands and which isomer show optical activity. It is Ma2B2C2 type. Here in this case, in Ma2B2C2 type of complex, total 5 geometrical isomers are possible. Here you can see all the structures of 5 geometrical isomers. But out of all 5, the central one where two similar ligands, they are adjacent to each other. Like these two amine, they are adjacent, chlorine are adjacent and bromine are adjacent. Only this geometrical isomer, it shows the optical activity because it doesn't possess any symmetrical property. So these two are mirror images of each other and they are non-superimposable mirror images of each other. So we can say these are isomers or enantiomers of each other. Next question is, what type of isomerism is shown by following different types of coordination compounds? So let's go one by one. See here, Ma2B2C2 type, it shows 5 geometrical isomers and 1 optical isomerism. This example we just discussed. While second is MAA2BC. Here AA, it's a symmetrical bidentate ligand. It possesses geometrical isomerism as well as optical isomerism both. MAB3 type, it possesses geometrical as well as optical isomerism, while MABCD type, it shows if it is of square planar geometry only, not tetrahedral, na? Square planar geometry, then it shows 3 geometrical isomers. This we have already discussed in various videos. Draw the structure of tetramine dichlorocobalt chloride. Tetramine dichlorocobalt ion. So, its structure is this, geometrical isomerism. Now here, how you can find out which one is cis and which one is trans? I already told you. As here 2 chlorine atoms, they are present on same side, so it is cis, and 2 chlorine atoms are present on opposite side, so it is trans isomer. Now, explain the different types of isomers shown by Dibromobilic, ethylene, diamine, cobalt ion. Now it is here ethylene diamine, it is a bidentate ligand. So let's discuss whether it can show which type of. Now here you can see this is the trans isomer, but it is optically inactive. Why optically inactive? Because it possesses plane of symmetry. Second thing, this here bromine, they are present on same side of the plane, so it is a cis form. And these two, they are mirror images of each other, but they are non-superimposable mirror images of each other. So this cis form, it possesses optical activity. Out of this, one is dextrorotatory and another is levorotatory. So we can say that Dibromobilic ethylene diamine cobalt, it possesses geometrical isomers as well as optical activity. In geometrical isomerism, it shows trans as well as cis. Trans is optically inactive, but cis form, it is optically active. Here, optical isomers, their structures are shown in detail. This is cis form because 2 chlorine atoms, they are adjacent to each other or they are present on same side, and here 2 chlorines, they are present on opposite side, so it is a trans form. Why tetrahedral complexes do not show geometrical isomerism? Tetrahedral complexes do not show geometrical isomerism. The reason is tetrahedral complexes, here you can see the shape of the tetrahedral complexes. Tetrahedral complexes do not show geometrical isomerism because the relative position of monodentate ligand attached to the central metal atoms are same with respect to each other. That means if you take any 2 ligands, they are always adjacent to each other and their position is same. Like these 2, they are adjacent. These 2, they are adjacent. Even these 2, as these molecules are identical and hence they cannot show. If you see these 2 molecules, they are identical. So we can't say one is cis or one is trans. If you see in this square planar geometry, see here 2 green, they are on same side, and here 2 greens, they are on opposite side. So when they are on same side, it is called as cis, and when they are on opposite side, it is called as trans. But such type of situation is not in tetrahedral complexes. In tetrahedral complexes, here you can see these two are there on same side. But here also, though they are going here, but they are also on same side. So you can't say whether which one is cis and which one is trans. Next is, why do square planar complexes do not show optical isomerism? We just saw that they can show geometrical isomerism. This one is cis and the upper one is trans. But square planar complexes do not show optical isomerism. Why? Because for a molecule to be optically active, it must be able to exist in two forms which are non-superimposable mirror images. The essential requirement for a compound to be optically active is that the compound should not have plane of symmetry in its structure. That means the molecule should be asymmetric. If the molecule has plane of symmetry, the object and its mirror image will be identical. They are not non-superimposable mirror images of each other and the compound will not be optically active. Square planar complexes have, you can see, square planar complexes have the plane of symmetry, means we can cut this molecule in two parts equally. So, as it possesses plane of symmetry, hence square planar complexes do not show optical activity. Only one complex, that is isobutylene diamine mesostilbene diamine platinum chloride, though it is a square planar complex, here you can see the structure. This is the only square planar complex which is optically active. This structure, if you see, it doesn't have plane or axis of symmetry, and hence it is unsymmetric and optically active. This is the only square planar complex known which is optically active. Complexes of type Ma4, Ma3b, Mab3, square planar or tetrahedral, do not show either geometrical or optical isomerism. Why? Now complexes of type, see the answer, complexes of type Ma4, Ma3b or Mab3 have no geometrical isomer because every possible arrangement for any of these complexes will be exactly same. Here in Ma3b, see the example of Ma3b. Here different structures are written, but if you see, all the structures are same. You can't see that these two are different or these two are different. All the structures are same, and as structures are same, no isomerism is possible. Give one example of optically active tetrahedral complex with unsymmetrical bidentate ligand. Actually, tetrahedral complexes which have been shown to be optically active are those which contain unsymmetrical bidentate ligand. The general formula of this complex, it is MAB and its structure is like this. This is the optically active tetrahedral complex. So here we have finished all the different questions based on isomerism of coordination compound, and here we finish this first chapter. Thank you so much.